This is a demonstration of transfer learning for image classification application. Using trained MobileNet-V2 model, 100% accuracy was achieved. First of all the important libraries are imported, including TensorFlow and Keras. The image is set to 224 by 224 pixels. And using Image Data Generator, the training data is being uploaded. So, you can see, there are 60 images belonging to 6 classes in the training image data. Similarly, the validation data is uploaded. There are 150 validation images belonging to 6 classes. And the 6 classes are printed here. Big container, in color blue and yellow. Small container with blue and green and yellow. And loader with red and yellow tractor. Now here the MobileNet-V2 model from Keras is loaded. This is just to see the original model. This is a very big CNN model with 53 convolutional layers. And finally, there are 1,000 classes, which are predicted through this model. And in total there are 3.5 million parameters, most of them trainable. This is an untrained original model. Now we will get an already trained model, so that we don't have to train it fully and we can get most of the trained parameters of this model, except for the last layer. Here, image size has been kept to 224 by 224, and trainable has been kept false, so that we get the already trained parameters. You can see in the summary, there are 2.25 million parameters. But all of them are already trained as trainable was set to false. The batch size of training image is 32 as default. And here the labels have 6 dimensions as it has been already encoded for 6 categories. Now, in this model which was extracted, we'll add a final layer with 6 categories. In the summary we have other than 2.26 million already trained parameters and 7,686 parameters which should be trained. Now, we compile the model with categorical cross-entropy. And we are using batch start callback to improve the performance. The model is being trained with our training image data. And number of epochs has been set to 8. This was based on experience while developing this. The accuracy on training data starts with 31% and on validation data with 44% over the first epoch. The loss starts with 1.87 and decreases over the consecutive epochs. The accuracy on training data and validation data gradually increases over the epochs. Finally, at the end of 8 epochs, Both testing and validation accuracy reaches 100%. The train model is used to predict category for the training data again, which will be shown later. Now testing image data is uploaded. The model is applied to predict the classes on the testing dataset. Now, to assess the performance of the model, classification report on testing data is printed. As we can see, the model has performed perfectly. The accuracy for each class, as well as overall accuracy, is 100%. We can see its performance better on the confusion matrix. It's clearly visible that all the numbers are along the main diagonal, and all the elements elsewhere is 0. This shows that all the 150 images belonging to 6 categories, with 25 images in each, have been predicted accurately without any false positive or false negative outcomes. Now, here is the loss value during the training. It has decreased over the epochs. Similarly, the training and validation accuracy over the epochs has increased and finally saturated to 100%. And the training and validation loss has decreased and converged to around 0.4.